Hello class, this is sine and cosine graphic part 2. They were phase shifts. So phase shift is really just the fancy way of saying your horizontal shift. In any other normal graph, it's your left or right shift, but because we talk about sine and cosine, we'd like to change the name. Just a reminder that your period is how long it takes your graph to repeat. And for all of your purposes right now, your period is going to be 2 pi. On day 3, we'll talk about what happens when you change the period. So, all these problems are going to look very similar to what they did yesterday, but now we're shifting left or right. So just like before, when you shift left or right, you always do the opposite of what the sign is. So this is positive pi over 3. So we're going to actually end up shifting backwards to negative pi over 3. So that's your starting point. And for those of you who like to make tables and things, you can certainly do that. It just depends on how your brain works. So now you need to figure out where you're going to stop. What is the end of your squiggly type graph? To find the end, you just have to add 2 pi on to pi over 3 because it takes your graph 2 pi to repeat. So you're going to have to do some adding and subtracting of fractions. And yes, this will be on the no calculator portion of your test. So you need to make sure that you can do this without a calculator. So when you're doing this practice independently, make sure that you can do it without a calculator. So you need common denominators here. The common denominator would be 3. So this is 6 pi over 3. So your graph is going to end or start back over at negative pi over 3 plus 6 pi over 3, which is 5 pi over 3. That's where we end. And then now you just have to find the middle. Because remember, there are 5 numbers in this summary. Usually it's 0, pi over 2, pi, 3 pi over 2, and 2 pi. But since we're shifting, all of those points have to shift. So now we're going to find the middle. The middle of the starting and the ending. To find the middle, you just take the average, which is kind of hard because it seems scary. You're going to take 5 pi over 3 and negative pi over 3, add them up, and then divide by 2. That's the average. So you have negative 1 plus 5, which is negative 4. And then you're dividing by 2. Technically, when you divide by 2, let's just say we multiply by a half. That's a little bit easier. So this is negative 4 pi over 6, which is negative 2 pi over 3. Cool. So we have 1, 2, 3 numbers out of our 5 number summary. Now let's find the middle of the start and the middle. So we'll come over here. We have to do negative pi over 3 plus, oops, this should be a positive. My apologies. That's a positive. That's a positive. Plus 2 pi over 3. And then we will divide that by 2 or multiply it by a half. So negative pi plus 2 pi is just a pi over 3 divided by 2 or multiplied by a half. So this is pi over 6. And then to find the fifth number, we find the middle of the middle and the end. So we have 2 pi over 3 plus 5 pi over 3. And then we add them up. So 7 pi over 3. And then we have to divide that by 2 or multiply it by a half. So it's 7 pi over 6. So here are the 5 numbers. We start at negative pi over 3, then we go to pi over 6, then we go to 2 pi over 3, then we go to 7 pi over 6, and then our ending point is at 5 pi over 3. So when you graph this, everything is the same as before, except you're starting on different numbers. I probably shouldn't have drawn my x-axis. Let's draw it right here. Now, we have the 3, that's our amplitude. So that means it's going to stretch 3. Our sine graph, remember, starts on the middle, goes down, and then comes back up. And then this, we determined all the way over here. So my starting point is at negative pi over 3. And then I go to pi over 6. Let's erase the x-axis for right now. And then my next number is 2 pi over 3. And then my next number is the 7 pi over 6. And then my last number is 5 pi over 3. So now we just kind of need to figure out the placement of our y-axis. Now our y-axis is not really directly in between pi over 3 and pi over 6. It's a little bit closer to pi over 6, so I'm just going to stick it right here in the middle. And now we will draw our sine graph. So we don't have a vertical shift, so we're centered on the middle. But we are 3 above the center and 3 below the center because of our amplitude. And then this is negative pi over 3, so this is right here. Start on the middle. And remember, we go middle, top, middle, bottom, middle. So middle, and then we go to the top on pi over 6. And then back to the middle at 2 pi over 3. And then down to the bottom at negative 3. And then we come back to the middle right here. So there's our sine graph. Now, if you wanted, you could certainly extend this and draw 2 periods of the graph. You just have to continue your scale in the correct way. And if you're good at noticing patterns, you kind of see, like you're going up by pi over 3 every time. Or sorry, you're going up by pi over, you're actually going up by like pi over 2 every time, I believe. So you can continue that pattern and add pi over 2, or you could just recognize that you have pi over 3, and then 2 pi over 3, and then 5 pi over 3. This is pi over 6, and then 7 pi over 6. So this next one would have to be, let's see what, those are 6 apart, so add 6, so 13 pi over 6. And then the next one's going to be a pi over 3. So that would be, and those are 3, so it would be 3 pi over 3, which is pi. Oh wait, no, that's not right. 8 pi over 3. And then add 6 more onto this one, so this would be 20 or 18 pi over 6. And I'm kind of running out of space. So you can always extend your graph out by just kind of recognizing the pattern if you need to. So use this information to do 4.4 practice day 2 in your packet. There are 8 questions that I want you to try and come in with questions for our next class period.